Welcome to another thrilling episode in the cosmos. Today, we're diving into a recent, breathtaking discovery by ENASA's James Webb Telescope, a story that's lighting up the universe. Get ready as we explore the enigma of strange lights emanating from a cold, failed star, a phenomenon that's got astronomers and space enthusiasts on the edge of their seats. Buckle up for this cosmic journey. The James Webb Space Telescope, famous for unveiling distant galaxies and mysterious black holes at the universe's edge, has now focused on something astonishing. It has captured a familiar yet breathtaking spectacle, the northern and southern lights, or auroras. These lights, typically seen at Earth's higher latitudes, are produced by solar particles colliding with atmospheric molecules. While our planet's magnetosphere directs these particles towards the poles, auroras aren't exclusive to Earth. Similar phenomena have been observed on Jupiter, Saturn, and moons like Enceladus, where solar particles ignite these light shows. Here's the exciting part. The James Webb Space Telescope, ENASA Marvel, has now identified an aurora surrounding a brown dwarf, a type of failed star. This groundbreaking discovery adds a new chapter to our understanding of stellar phenomena. Located over 40 light-years from Earth, the brown dwarf W 1935 has puzzled astronomers due to its isolated location and lack of nearby stars to provide the charged particles usually needed for aurora formation. Brown dwarfs, bigger than gas giants, but smaller than stars, form from gas and dust cloud collapse, akin to stars. However, they're dubbed failed stars as they can't sustain hydrogen to helium fusion, a process central to stars' main sequence life. The James Webb Space Telescope's detection of infrared and solar radiation emissions, especially related to methane, hinted at a potential aurora around W 1935. On Jupiter and Saturn, methane emissions occur when charged particles, following magnetic field lines, collide with atmospheric molecules, creating auroras. This discovery suggests a similar phenomenon could be happening with W 1935, challenging our understanding of these solitary celestial bodies. The unexpected twist in the observations of W 1935 was that, contrary to expectations, the methane didn't absorb light but instead emitted a glowing light. This left the scientists initially baffled. The question arose, why would methane be emitted from a brown dwarf, particularly when it lacks the external solar wind typically associated with triggering auroras? The research team speculated that an internal process within the brown dwarf might be energizing its atmosphere. Another theory is that interstellar plasma could be colliding with W 1935. Alternatively, the brown dwarf might not be as isolated as thought, possibly interacting with particles from a nearby active moon. Of course, there could be other explanations, and further observations are needed to clarify this mystery. Auroras have been used to interpret unusual features of brown dwarfs, such as radio emissions from the warmer ones. However, the James Webb Space Telescope's discovery of methane emissions from W 1935 marks a first in detecting such a phenomenon, hinting at the presence of an aurora on a brown dwarf. This incredible discovery of an aurora on a brown dwarf propels us into exploring the chemistry of such phenomena, comparing auroral activities beyond our solar system with those we know. But the revelations don't stop there. In early 2024, the telescope has made another startling observation: galaxies that oddly resemble pickles. Long-held assumptions by astronomers posited that early universe galaxies would be orb-like or disc-shaped, similar to those in the current universe. However, images from the Webb telescope have upended this notion. Surprisingly, these infant galaxies from the universe's early days look more like bananas. This unexpected finding came after astronomers re-examined images of about 4,000 such galaxies captured by the telescope. If these observations hold true, they could dramatically alter our understanding of galaxy formation and expansion. Moreover, This could offer invaluable insights into the cosmic processes at play, significantly advancing our knowledge of the universe's infancy. The discovery of the banana-shaped early galaxies not only intrigues but also challenges our understanding of dark matter, a mysterious and unseen component believed to make up a substantial part of the universe. Interestingly, despite these findings being in line with previous observations from the Hubble telescope, which hinted at similar shapes, many astronomers remain skeptical. Dr. Alan Dressler from the Carnegie Observatories, instrumental in developing the James Webb Space Telescope, voices such skepticism. Although not directly involved in this specific research, Dressler expresses doubts about the findings, highlighting the challenges in accurately measuring distant, small, and faint galaxies. To explore these unique shapes, the scientific team conducted a statistical analysis of the galaxy's two-dimensional projections against the sky, aiming to deduce their three-dimensional forms. This discovery has significant implications for the fields of astrophysics and cosmology. It challenges existing theories and models, potentially leading to new understandings of stellar formation and evolution. As we delve deeper into the study of brown dwarfs, we might find answers to some long-standing cosmic questions. The role of cutting-edge technology in modern astronomy cannot be overstated. The James Webb Telescope, with its advanced instruments and capabilities, if these early galaxies were spherical or disc-shaped, as traditionally thought, with random orientations in space, astronomers would expect to occasionally see their complete, round faces in the telescope's observations. Contrary to expectations, the telescope observations revealed an abundance of galaxy shapes more akin to cigars and bananas. Dr. Pawa, the study's lead author, observed that these galaxies were strikingly linear, some featuring multiple bright spots aligned like pearls on a string. These elongated galaxies, comprising about 80% of the galaxies in the Cosmic Evolution early release science sample, are uncommon in the current universe. Yet, they are thought to be the ancestors of galaxies like our Milky Way, indicating that our galaxy might have once exhibited a similar cigar-like or surfboard-like shape. In the contemporary universe, galaxies are typically classified into two main shapes: elliptical clouds and flat, disc-like structures, like the Milky Way. However, these initial observations show that the earliest galaxies did not start off resembling these familiar forms. In 1926, Edwin Hubble introduced the Hubble sequence, categorizing galaxies into three types based on appearance: ellipticals, lenticulars, and spirals. In 2010, a group of European astronomers used data from the Hubble Space Telescope for a comprehensive survey of galaxy types and shapes, furthering our understanding of galactic morphology. The study, encompassing a timeline from the early universe to the present, included 116 local galaxies and 148 distant galaxies. Strikingly, the results indicated that the Hubble sequence from 6 billion years ago was significantly different from the current one. At that time, peculiar galaxies were more prevalent, suggesting a transformation of these unusual galaxies into normal spirals over the last 6 billion years. This implies that collisions and mergers played a significant role in galaxy evolution, even after it was believed that galaxy mergers had diminished around 8 billion years ago. The study also revealed that spiral galaxies are relatively recent formations compared to other galaxy types. Moving to the present, the James Webb Space Telescope continues to reshape our understanding of the universe. Its latest findings challenge the standard cosmological model, which posits that galaxies evolved from amorphous structures composed of primordial hydrogen and helium. According to this model, galactic collisions and mergers were frequent in the early universe, eventually leading to the development of disks and spirals. Thus, spiral galaxies were expected to be more prevalent in the local universe, but scarce in the early universe. A team of scientists analyzing data from the Cosmic Evolution Early Release Science Survey conducted by the James Webb Space Telescope studied 873 galaxies with redshifts between 0.5 and 4. This range corresponds to galaxies aged between 5 billion and 12 billion years. Of these, 216 were identified as spirals, and 108 were unanimously agreed upon as spirals, despite potential misclassifications. When examining these galaxies based on their redshift, the researchers found that the proportion of spiral galaxies decreased the further back in time they looked. However, surprisingly, at redshifts above Z equals 3, about 11.5 billion years ago, the number of spiral galaxies was much higher than anticipated. After calibration, it was estimated that around 1/5 of the galaxies at Z equals 3 were spirals. This revelation suggests that these ancient galaxies had evolved into spirals less than 2 billion years after the Big Bang, leaving a relatively short window for mergers and collisions to be the predominant shaping force. In other words, while mergers and collisions do contribute to the formation of spiral galaxies, there are other significant factors at play in their early evolution. In summary, the James Webb Space Telescope has astounded us yet again, this time by revealing an aurora around a brown dwarf, which intriguingly lacks neighboring stars. This fascinating discovery challenges our current comprehension of these solitary celestial bodies and paves the way for new exploratory paths. The James Webb Telescope, ENASA's eye in the sky, has struck gold, or should we say light. It spotted unusual luminosity coming from a distant, cold, failed star. This discovery isn't just about pretty lights, it's a window into the mysteries of the universe. Before diving deeper, let's understand what a failed star, or brown dwarf, is. These celestial bodies are intriguing cosmic entities, larger than planets, but not quite making it to star status. They lack the mass to ignite nuclear fusion, the power source of stars. So, what makes these strange lights so special? These illuminations could be evidence of unknown astrophysical phenomena. They challenge our understanding of brown dwarfs and potentially rewrite some cosmic rules. This discovery is just the beginning. It opens new doors for space exploration and our quest for knowledge. What other secrets do these cold, failed stars hold? The answers lie in the vastness of space, waiting to be uncovered. The investigation into these strange lights is in full swing. Scientists are using Webb's advanced instruments to analyze the light spectrum, hoping to decode the composition and behavior of this distant object. This analysis is crucial in understanding the physics of brown dwarfs and their place in the cosmic landscape. An interesting aspect of this discovery is the role of gravity. Unlike full-fledged stars, brown dwarfs have weaker gravitational pulls. This unique characteristic could be influencing the strange lights we're seeing, possibly revealing new insights into gravitational interactions in the universe. Comparisons with other celestial bodies are vital in this study. By contrasting the luminosity and characteristics of this failed star with those of other brown dwarfs and stars, scientists hope to unravel the peculiarities that set it apart. This comparative analysis is a cornerstone in astrophysical research. One tantalizing question arises: what does this discovery mean for the search for alien life? The conditions around brown dwarfs are vastly different from those of stars. Understanding these environments might reshape our search for life beyond Earth, expanding it to new, unexplored frontiers. This discovery isn't just for scientists, it's capturing the public's imagination. It's a reminder of the endless mysteries of the universe, encouraging young and old alike to look up and wonder. Teams of international scientists, engineers, and researchers have come together, pooling their expertise to make sense of these observations. This cooperative approach is essential in unraveling the universe's secrets. The educational impact of such discoveries is profound. They provide real-world examples for STEM education, inspiring the next generation of astronomers and scientists. One of the lesser discussed yet critical aspects of such missions is the challenge of deep space communication. The James Webb Telescope, located far beyond Earth's orbit, relies on sophisticated communication systems to transmit its findings. Understanding and improving these long-distance communications is crucial for the success of future deep space missions. This discovery has significant implications for the fields of astrophysics and cosmology. It challenges existing theories and models, potentially leading to new understandings of stellar formation and evolution. As we delve deeper into the study of brown dwarfs, we might find answers to some long-standing cosmic questions. The role of cutting-edge technology in modern astronomy cannot be overstated. The James Webb Telescope, with its advanced instruments and capabilities, exemplifies how technology is pushing the boundaries of what we can observe and understand in the universe. This marriage of science and technology is vital for future discoveries. This discovery is not just an end, it's a beginning inspiring future space missions. It opens up new areas of investigation and may lead to the development of more advanced telescopes and probes, aimed at exploring these and other cosmic phenomena in greater detail. The strange lights from the cold, failed star raise questions about cosmic weather patterns. In the case of the James Webb Telescope, AI algorithms help process vast amounts of data, identifying patterns and anomalies that might be missed by the human eye. The integration of AI in space research is revolutionizing our approach to understanding the cosmos. The James Webb Telescope is not just a scientific tool, it's an educational powerhouse. Its findings are being used in classrooms around the world to teach students about space, science, and technology. By providing real-world examples of scientific discovery, it's inspiring a new generation of learners and future scientists. As we launch more missions into space, environmental considerations become increasingly important. The James Webb Telescope's mission includes measures to minimize space debris and ensure a sustainable approach to space exploration. This aspect of space missions is crucial for maintaining a clean and safe space environment for future explorations. Collaborative efforts, pooling resources, and sharing knowledge across countries and agencies like NASA and ESA enhance our capabilities to explore and understand space. Such cooperation is essential for tackling the complex challenges of space exploration and science. The public's engagement and interest in space science have been significantly bolstered by discoveries like this one. Such enthusiasm is crucial for the continued support and funding of space programs. It also plays a vital role in inspiring future scientists, engineers, and astronomers who will carry forward the torch of exploration. The discovery of strange lights from a cold, failed star also revitalizes interest in the hunt for exoplanets. With the James Webb Telescope's advanced capabilities, we're poised to discover and study more exoplanets, possibly uncovering Earth-like worlds. This exploration could answer fundamental questions about the existence of life beyond our solar system and the diversity of planetary systems. This discovery also has a significant impact on the field of astrophotography. Amateur and professional astronomers alike are inspired to capture their own images of the cosmos using increasingly sophisticated equipment. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions, updates, and awe-inspiring visualizations of the universe. Live Q and a sessions with experts. Your membership will grant you the chance to participate in live Q and a sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.